Let's do practice problem 9 on page 231, and this is what it says. A box weighs 575 newtons and is lifted a distance of 20 meters straight up by a cable attached to a motor. The job is done in 10 seconds. What power is developed by the motor in watts and in kilowatts? So given. So here's our cable, and here's some box. It's quite heavy. Okay. Add a little three-dimensional quality to it. So we'll have the cable kind of attached like this. There it goes. And it's going to wrap around this pulley, and it's going to have a motor attached to it. We're going to lift it. Delta Y equals 20 meters. And the time it takes to do that is 10 seconds. And of course the weight of this crate pulling down is 575 newtons. And we want to know, let's put find down here. Find power in watts and in kilowatts. I'll just solve it right next to it. Right here. So power equals the work done divided by the time it takes to do that work. And so we need to figure out how much work was done. Well, work is the force that you have to lift up times the displacement, in this case delta y, times the cosine of the angle between these two vectors divided by time. And well, let's go through it. Now the force on the cable, if we draw a free body diagram of this crate, here's gravity, and here's the force of the tension on the cable, and these forces are going to be equal and opposite once I get it going. I mean, right at the first instant in time, you have to get it from 0 to some whatever speed you're lifting it. But once it reaches that speed, this force and that displacement, this force and the weight will be essentially the same. So the force that's being applied is essentially the weight of the crate. 575 newtons times delta y, 20 meters. And the force we're applying is up, and the displacement is up. So that's a cosine of 0 degrees. And it takes 10 seconds for all that to happen. And let's see, this is 1. Well, 20 divided by 10 is 2. And 2 times 575 is, what is it, 1,150? Is that right? And what's a newton? Newton times a meter is a joule. A joule per second is a watt. Now to express the power in kilowatts, a kilowatt is 1,000 watts. So you divide this by 1,000 and the watts will cancel. Let me just write it out for those who need it. It's just a unit conversion. 1 kilowatt is 1,000 watts. Whenever you see kilo, that means 1,000 of something. 1,000 watts. And you get 1.15 kilowatts. And that's how you do that. Okay. Let's see if we can get the whole thing here. Any questions? Yes? Well, what is the angle? And the question is, why isn't this 90 degrees? Well, what is the direction of the displacement and what's the direction of force? Remember this angle right here? What is this the angle of? It's the angle between the force vector and the displacement vector. Well, the force vector here, we're pulling up. But what's the direction of the displacement? Up. So because the force and the displacement are in the same direction, there's no angle, right? It's 0 degrees is the angle between the force and displacement. Does that answer your question? And then the cosine is 1. And what that means is all the force is doing the work in this problem. It's not like a force that's at an angle to the displacement where only a component of the force is doing the work. All of the force is doing work on our box. Any other questions? Okay. That is all.